Welcome, my dear student. So, in this lecture series, I am going to solve some of the interesting and challenging numerical problems from the book Physics Pathfinder. So, let us start with the session. So, there is a situation where a bungee jumper is jumping from the top of a tower. So, the information is given. So, you are asked to calculate the maximum length of the cord. Okay, so whenever the bungee jumper is jumping, let us say this is the, as per the problem, let us say this is the tower. On top of the tower, the bungee jumper is jumping. Let us say this is the height, capital H. It is given as 62.5 meter. Okay. Now, once the jumper is jumping, let us say this is the initial location of the jumper, whose height is given as small h. Bungee jumper height is small h. Let us say this is the jumper whose height is small h. So this is the small h height. Small h height. And he comes to downward direction up to this much point, let us say, which is at a clearance distance of d from the ground. So it is given that the ground clearance should be a d number. Now this is the position of the jumper at this position. Let us say this is the height h. This is the height h. Now total height dropped. Initial position is the bungee jumper position is this one. A is the initial position, and let us say B is the final position. Now, can I say the drop in height? So, this is the drop in height. How much? That is equals to capital H minus small h minus d. So, capital H minus small h minus small d. So, this is the height change. So, because of that, the potential energy will come. Potential energy will come. Let the natural length of the string that has been used is x. Let us say I am saying x is the natural length of the string. Now, total length of the string is given as L0, that is 30 meter. Total length of the string is given as L0, that is 30 meter. Now, some portion of the length is being used. Okay. So, if I say L0 is the total length, so if I say effectively how much portion of the length of the string is being used, that depends on the value of natural length. So if I say for L0 length, the spring constant is K, or stiffness constant is K. But for X length, the stiffness constant will be different. So there is the effective string constant. The effective string constant should be equal to how much? K times L0 divided by X. Okay. So since the entire length of the rope is not utilized, so you have to consider the effective value of K. So now I can do the energy balance. So potential energy, that is the gravitational potential energy, is lost, and the gain is the kinetic energy basically, or the string potential energy. So now loss in gravitational potential. Now what is that loss? That is equals to mg. So what is that? That should be equals to mg into h is how much? Capital H minus small h minus d. Okay. And what is the gain in potential energy of string? The string potential energy is given half k x square. Now k is k effective. So k L0 by x. Now what is the elongation? Elongation is basically h minus d minus h, that number minus x. So x is the natural length. So from natural length, the string has been extended by this much portion. So that should be equals to capital H minus small h minus d minus x whole square. Okay. So that is the, now if I simplify this, that becomes a quadratic in x. So once I simplify this will give 2mg into x. 2mg into x divided by k into L0, that number into capital H minus small h minus d, that should be equals to our h minus h minus d minus x whole square, this number. Now let us say I take mgx by kl0, this number is mg by kl0. Let us say substitute mg by kl0, that number is, let us say alpha. I put this number as alpha. and capital H minus D and capital H minus D as beta. If I substitute this, then it becomes a corresponding equation become how much? That means 2 alpha times x into beta should be equals to beta minus x whole square. Okay, so it becomes a quadratic in A. So ultimately what we can say, if I simplify this, so I can write the equation of quadratic equation in terms of x as x square minus 2 beta x into alpha plus 1 plus beta square, that is equal to 0. Okay, the solution of this gives the value of x. So x gives answer is equals to, if I simplify this, so ultimately what I am getting that number is beta into alpha plus 1 plus minus root of alpha plus 1 whole square minus 1. So this is the value of x that I am getting. So once I put the value of alpha and beta in this equation, so what we can finally conclude that x number cannot be greater than, how much? That is h minus this will be the maximum possible level. Okay, so naturally it must be less than that. So x cannot be greater than this number. So ultimately, once I use this assumption, so what we got, the value of x, finally I got it as h minus d into mg by KL naught plus 1 minus root of mg by KL naught plus 1 whole square minus 1. Okay, so that is basically the value of x. So once I put all those numbers, we can get the value of x in the numerical answer type. So this part is over. So if you calculate this, ultimately get the x value, that is our answer. Yeah, that will be our answer. So please mention in the comment box what the answer you are getting. Okay, so this is the final value. Just simplify it to get the correct answer of x. Hope you understand this. Thanks for watching the video, and if you like it, please subscribe my channel.